Alright guys, this is your test review for the test you're going to take on Tuesday, January 23rd. This video is for problems 1 through 5. So we're going to start with number 1. 2 examples of graphs with exponential growth. So remember that means that our graph is growing from left to right. So it's going to start low. Let's say our asymptote's at 0. It's going to start low and extend upwards. If your asymptote moves, like let's say it gets moved down, our graph will then have an x-intercept. Okay. 2 examples of graphs of exponential decay, meaning it is going to decrease in value. So it's going to start high, and if our asymptote's at 0, it's going to decrease down but never cross over that line. Again, if our asymptote moves, let's say it's positive this time, it gets moved up. It'll still get real close to it but never touch. All right. So these guys are my growth. And then these 2 are our decay functions. All right. Number 2, what are the intercepts of the exponential functions shown below? So it wants to know intercepts. So we have 2 of them. There's an x-intercept right here, and there's a y-intercept right here. Okay. So our x-intercept is where it intercepts the x-axis. Okay. This point is directly in the middle between 0 and -2. This is an x value of -1. That point is -1, 0. Make sure we write it as a coordinate point. Okay. Our y-intercept, where it's crossing our y-axis, right here, is also happening at -1. So since my x is 0 and my y is -1. So make sure you know how to write these 2 as coordinate points. X-intercept has a y of 0. Y-intercept has an x of 0. All right. Here we go. Number 3. We are going to determine the end behavior. Okay, and it gives you the horizontal asymptote. So it tells you that this is at -4. Okay. So as x approaches negative, meaning as my x's get smaller and approach -infinity, right? The graph itself is decreasing, but it's going to get real close but never cross over the asymptote of -4. On the other side, as we're going positive infinity with my x's, my graph is also increasing and nothing is going to stop it, so it's going to continue until it reaches positive infinity. All right. Part B, it's a little tricky. Okay, this one has been reflected, but we can still do it. Okay. My horizontal asymptote is at y equals +1. Here we go. As x approaches negative, so as we move over to the left to -infinity, where is my graph going? It is going down. It's going to go to the y's of -infinity. Nothing is stopping it this time. All right. As we go to the right side, as positive infinity for my x's, my graph is increasing, but since it's been reflected, now the asymptote is blocking the upward movement of my graph. So this is going to be blocked and approach +1 and not go any higher. All right. Number 4, we're going to label these as growth or decay. Remember, when we're looking at this, we're looking at our base, okay? And our base is usually in the parentheses. Most importantly, it's what's directly connected to our exponent of x, okay? If the base is bigger than 1, it's going to be a growth, okay? If our base is less than 1, but it's still bigger than 0, meaning it's a positive number, okay, that is less than 1, it is going to be a decay function. All right, so let's look at our bases. Here we go, 0.68. That is less than 1. Therefore, this is going to be a decay function. B, my base is 3/4. 3/4 is the same thing as 0.75, which is less than 1. This is also going to be a decay. Part C, my base is 4. That is bigger than 1. This is a growth. Part D, 7 is my base, which is bigger than 1. So this is also a growth. All right. Moving on to number 5, we have our first word problem. This is the amount of money accrued, that means gathered, at the end of t years when a certain amount P is invested at a compound annual rate. Okay, that means just once a year. Okay, so we're just going to use this guy. Okay. If a person invests $1,250 in an account that pays 6% interest, compounded monthly. So that means I need to divide my rate by N, and I get to multiply my T by the N value. Find the balance after 10 years. All right, here we go. My P is my starting amount, so therefore $12.50 is our P value. So $12.50. 1 plus our rate is 6%, so remember we need to take 6% and move our decimal over twice. So my rate is actually 0.06. It's happening more than once a year because now it's telling me it's compounded monthly. Okay, so if it's going to happen each month, it's going to happen 12 times a year. And it's happening 10 years. So we're going to have 10 times 12. All right, how much are we going to have? Well, we're going to use our calculator. All right, so $12.50, we're going to type in exactly as you see it. 1 plus 0.06 divided by 12 raised to the 10 times 12. All right, so looks like after 10 years, we're going to have about $2,274 and about 25 cents. Okay. You could have also put it into your y equals if you wanted to. 12.50, 1 plus 0.06 divided by 12, but then you would have raised it to the 12x. And then you could have gone to your table. This is all the years, and you could have looked at year 12. And year 12 gives us that same, not year 12, I'm sorry, year 10 gives us that same amount. So the 2,274 and 25 cents. All right. So that's the first section. The next video will go on to the next section of the test review.